We're going to pick up where we left off yesterday. Yesterday, we got to the point of having our data table on our Google Sheet and our graph on Google Sheet. If you had trouble plotting that graph, we'll ask you just to go back to the podcast that we recorded yesterday, have a look at that, find all the details of it, and if you still can't figure it out, come and ask me a question. Now, today, what we want to do is do the actual lab write-up. Now, I've told you guys that we want to have nice, tidy, neat data tables. This looks pretty good to me. We've deleted all of that data that doesn't matter, the acceleration, the velocity, the timestamp, and so on. But there's a couple things with this data table that I don't like. The first thing I don't like are my decimal points. I see my first data point is 3.55, then 3.6. That's okay, but I'd rather say 3.55 and 3.60. I'd rather have the same number of decimal places. So I'm going to type in 3.60 there instead of 3.6. If I can find my mouse here. So I'm going to go to this now, 3.6, and I'm going to change it to 3.60. Now, watch what happens when I change it to 3.60. It just rounds it to 3.6 again. That wasn't very helpful at all. Google Sheets will do that. If there's a point zero after something, it'll just truncate it, it'll just round it. And normally that's not a big deal, but in a table like this, we want it to be formatted uniformly. It's a little bit bigger of a deal. So I'm going to show you how to do that. I'm going to show you how to make all the decimal places the same. Let's highlight that entire row, the whole row. And then I'm going to go up here to this little spot where we see the decimal 0, decimal 0, 0. I'm going to try increasing the number of decimal places. Oh, look, it increased them all to 3 decimal places. I don't really need 3 decimal places. Let's go back to 2 decimal places by reducing the number of decimal places. Now they're all 2 decimal places. This is good. I like the look of this better. Now let's do the same thing with my second column. Now, we do want to have the same number of decimal places within column 1, but it doesn't have to be the same number of decimal places as we have in column 2. So I'm going to do the same thing to column 2, but I think I'll go 4 decimal places for column 2 instead of 2 decimal places. Let's do the same thing. Let's increase the decimal places. Oh, that gives me 5. Okay, let's go back down to 4, and that looks good. Now this looks pretty good, but I want to go a little further in making this neat and tidy. I'm going to center everything. I want to center my data. I want to center my headings there. So what I'm going to do for that is to literally highlight all of my data. And the easiest way to do that is to highlight the columns. And then I'm going to click on this little symbol up here, which means justify or horizontal align. I'm going to click on the center one to center align it. That's going to put all my numbers and my headings in the middle of each column. Now that looks really good, actually, especially the first column. You got an issue with the second column here. Looks like a little bit of it's cut off. So I'm going to just widen that second column. To do that, I'll just click on that little that little column border there, drag it over a little bit, make it a little bit wider, and that looks good, right? It doesn't change my graph at all, but it does change the way my analysis table that produces my graph looks. It doesn't change the substance of my data, it changes the look of my data to make it a little bit neater. All right, now we're ready to write this up. So what we need to do at this point is go into Google Classroom. Now I'm going to go to Google Classroom as a student here, not as a teacher. So we see on the right-hand side here, your work. That's what you've seen, for the last number of years as you're completing assignments in Google Classroom. What I just worked on in that copy of my data that we collected yesterday, that's not in Google Classroom. I want to add that to Google Classroom. So I'm going to go over here where it says add or create from Google Drive. What I was just working on is in my Google Drive. You guys put it in that special folder in Google Drive yesterday. The easiest way to find that, though, is to look under recent. If we were just working on that, it should be the last or the first thing that appears under that recent category. So we shouldn't have to look for it at all. Now I'm going to click on that. I'm going to click add. And it doesn't seem, to be there. Oh, yeah, there it is. Oh, that's not it. Let's try it again. I don't know why it didn't appear. Copy of exported data, that's it. Let's add it. Now what I want to do is click on my write-up template. That's the one that has the little magenta color rows columns on there. So this is your template. You're always going to get a template. Sometimes that template will give you the problem in the lab. Sometimes it won't. This time I do. Remember, if you're not given the problem, you want to always phrase it in the form of a question. That's not a big deal, right? I'll always tell you what you're going to do. Sometimes you have to phrase that in the form of a question yourself. Sometimes I will have already phrased it in the form of a question, like I have this time. What haven't I done? I haven't written in the title of the lab, but I have given you the title of the lab. I said it's constant velocity lab. So I'm going to just type in constant velocity lab. And now, I didn't do this on purpose actually, but I see a little red underline there, which reminds me that I made a spelling mistake. So I'm going to go back and fix that. There's zero excuse for having a spelling mistake when Google Docs tells you you have a spelling mistake. Okay, that's just, well, let's be honest about it. That's just a lack of effort, right? We need to proofread. We don't even have to proofread hard because we just need to look for the red lines underneath it to know that we made a spelling mistake. Let's try that again, constant velocity lab. And this time, it's not giving me the little red line underneath it, so I know that I've got it spelled correctly. All right, I'm going to leave everything that's in magenta here for now. These are all the instructions. I am going to want to delete that stuff before I submit it, but I'm going to leave it now so that I can always go back and look at those instructions again, just to make sure that I've done everything right. So I'm going to scroll down here. Problem is done. The variables, I was thinking yesterday that I hadn't indicated that you should include the variables, but it does say that if you look under the lab, the assignment, it says to include variables, and it's in the template. So therefore, you need to include variables. We have three variables, or three sets of variables. The first one is the manipulated variable. And all I'm going to do to identify the manipulated variable is type the word manipulated. Manipulated dash, what's the manipulated variable? What is the manipulated variable in this graph, or in this lab? There should be a nice, easy way of determining what the manipulated variable is. You guys just plotted a graph, right? What's my manipulated variable? Yeah, David? Time, yeah. Now, I don't expect you to justify why you said time. Some teachers do, I don't. I'm fine if you just write manipulated variable is time. Don't write me a sentence here. I don't want to read a sentence here. Don't say the manipulated variable is time. Just say manipulated dash time, done. Don't say manipulated dash time because blah, 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 blah. I don't want to see that. I want to see manipulated dash time, period. Now, my responding variable, which is always my second set of variables, there's only one of them. Respond, can't spell that. There we are, responding dash, what's my responding variable in this now? Easy, right? No, it's not the velocity of the car. It's the position. We look at our graph, we see time and position on a graph. We know that time is the manipulated, position is the responding. The manipulated and responding variables should normally be pretty straightforward for us to find because normally we will plot a graph, and a graph always shows us responding versus manipulated variable. Now, we have control variables. There's a million control variables. I only expect you to list a couple control variables. Usually, there's a couple that are critically important. There's lots of them, right, that that are technically control variables, like the temperature should have remained the same. Is that really going to affect the dynamics card speed? Probably not, right? So that's not one we want you to list. What's something that's important that it was kept the same? Now, we only did one trial here, right? And it only lasted a few seconds. But for those few seconds while the experiment lasted, what couldn't change? Otherwise, it would mess everything up. The cart, yeah. I mean, odds are we're not going to change the cart midstream, but if we did, it would mess everything up probably, right? So let's keep the cart the same. Now, you don't need to say same cart. Now, I would mark it wrong if you said same cart, but if you say the word same cart, that's redundant, right? If I'm saying what's a control variable, if I'm saying what's a variable that stays the same, the answer to it is the cart, not the same cart, right? Does that make sense, you guys? Again, I'm not going to take off a mark if you say same cart, but it's not necessary. Cart is sufficient. Okay? If I have the word control beside that, that means same cart already. What else couldn't change between the start of this experiment and 3 seconds later when this experiment was over? The track, yeah. I'm going to add one more to it. The cart, the track, and yeah, like the slope of the track. What did we want, Alex, the slope of the track to be? Yeah, it's zero, right? Like horizontal, right? So in other words, we wanted a level track, right? Yeah. So let's just say that. Let's say track angle, and I'll put in brackets level. Now the reality is, guys, typically 2 important control variables are sufficient. We'll just put the 3 this time. That's fine. Okay, variables are done. Let's go down to materials and apparatus. These are listed. Notice the word list is italicized. Yeah, question? Yeah. The word list is italicized. We're not writing a paragraph here. I don't want to see a paragraph that describes all these materials. I want to see a list. And that list is going to have a little dash. What's the first variable that we used? Or sorry, the first material that we used? Yeah, go ahead. We used a cart. Let's be specific. The problem here was to find the velocity of a low friction dynamics cart. So let's say, yeah, good. Let's say low friction dynamics cart. Now, what else did we use? Yep, we used a phone. Now, I think yesterday I listed phone third as opposed to second. Does that matter? No, what order I list them, it doesn't make any difference in the world, right? You list phone second, you list phone third, that's fine. What else did I use? We use the track, right? Now, we don't want to list, whoops, I said tack. We're going to say track. We don't want to list extraneous data. That means extraneous materials. That means materials that aren't really relevant to the experiment. In other words, we don't want to list like paper towel, that was used to clean up a spill 5 minutes before the experiment began, right? Like that would be extraneous data, or sorry, extraneous materials. We don't want to list that you sat on, like you rested your elbow on a textbook, or like anything irrelevant to the actual experiment, right? We don't want to see extra stuff. All right, let's go back down here now, down to data and observations. Oh, beautiful. Data and observations, I love filling this in because I've already done it. Let's go back to my spreadsheet. Let's highlight all of my data. Once it's already been formatted, it's easy. You can format it within Google Docs, but it's easiest to format it within Google Sheets. So I'm going to suggest you format it in Sheets like we did, and then copy it over to Google Docs. Copy, Control-C. Now I'm going to go into Docs, and I'm going to paste, Control-V. Now, it's going to give you an option to link to spreadsheet. Do that. That way, if you make any changes to your table, it will automatically adjust them in Google Sheets or in Google Docs without you having to recopy and repaste. So I'm going to say, yes, link to spreadsheets, and I'm going to click paste, and then my data table is going to appear. Now, I don't want that data table to be spread over 2 pages, but I'll worry about that later on once I'm tidying things up. What's something else that I need for my data table that I haven't yet put in there? Told you about this yesterday, though, Daniel. No, graph is not data. The graph is analysis. Once I do, the data is just what I collect during the experiment. Once I do a calculation, that's analysis. Once I do a graph, that's analysis. What's something else that I need with my data that I haven't included yet? Yeah, go ahead. We need a title. And the title will always be Table 1. Or, well, if the first table is Table 1. If you had 3 tables, it would be Table 1, Table 2, Table 3. Table 1, colon, not Table 1 dash, it's Table 1, colon. And then we're going to say position of cart as a function of time, or something to the gist of that. It doesn't have to be those exact words, but something to the gist of position of cart as a function of time. Okay, data is listed there. Again, we're going to tidy that up a little bit later once we delete all this pink stuff. Now let's go down to analysis. If we had done calculations, that's where they would appear in the analysis. We didn't. But we did plot a graph. Graphs always appear in analysis. Graphs will never appear in data. So let's go over here to my spreadsheet. Let's go to my graph. Let's click on those 3 little dots in the top right-hand corner, and let's copy that chart. Now that it's copied, let's go into my write-up, and let's go Control V. Link it to spreadsheet? Yes, we always want to link it to spreadsheet. Now, we want that graph to take up the entire width of the page. If it's narrower, make it wider. We want it to take up the entire width of the page because we want it to be visible. I've got all the requirements there, the title, position versus time, my initials afterwards. I've got my equation listed here. I've got my trend line. I even changed the color of my trend line, not that you need to do that. My axes. Now I got some analysis questions. I got a position versus time graph. What does a straight line on a position versus time graph represent? No, it doesn't mean that at all, actually, because the position is changing the entire time. Constant velocity, yeah. So we're going to say the straight line represents constant velocity. Or something to that effect. Your words don't have to be exactly the same as mine, right? We want to have the right answer. It doesn't have to be the exact words. Let me take this chance, actually, to make a point. It is okay to copy my words here. But if you're working on next lab with somebody else, that's okay to work on it with somebody else. Talk about things, right? For sure, to help each other with things. But you are not copying the same words. Does that make sense, you guys? If I'm a student and you're a student and I'm typing in this, you're not typing in the same thing. You guys have talked about the answer to the question, and then you're creating your own answer to the question, if that makes sense. Goes with everything else on the lab as well. I talk about everything, but your own words for everything as well. Okay, what's the average velocity if the cart is shown by your position versus time graph? Well, yours is going to be different than mine, but mine is, I don't know if you can see this from where you're at, negative 1.03. We should have a number times x plus a number. That's in the form of, you can see on the board here, y equals mx plus b, negative 1.03 times x plus 3.15. 3.15 would be the y-intercept, negative 1.03 would be the slope. That's my velocity, right? The slope of the graph. So I'm going to say the average velocity is negative 1.03, and don't forget your units here, negative 1.03 meters per second. You don't really see too much of a curve on mine, but on many of yours you will see a slight curve. If you look over the whiteboard here, it's going to look either like this, like one of these two graphs, although this is highly exaggerated. Okay, if you look closely at yours, it's probably going to curve a little bit like this, although not nearly as pronounced as that, or like this, not nearly as pronounced as that. What does that mean? Okay.
If your velocity is positive, it's not like a little positive.
No, you don't. If it's positive, you can write the positive in there, but you can leave off that as well. The only time you need the sign is if it's negative. Okay, what does that mean, guys, if we have a little curve on that graph? Well, what is it doing? Did the cart speed up or slow down? Why would it slow down? Why is it losing speed? Well, we stopped it at the end, yeah, but we deleted that data when we stopped it, right? Yeah, yes, but you're getting a little bit bigger than you have to get there. No. Yes, but why? Friction. There's a little bit of friction there, right? So we'd say, why is there a slight, what does a slight curve represent? Say it represents the cart slowing down, or you could say decelerating. This would occur because of friction, or something to that effect, you could say. All right, next, almost there. Your conclusion. I'll give you time to come back to these as well to tidy things up. So don't panic if you're not quite keeping up with it here. Your conclusion. Remember yesterday we said the conclusion answers the problem. The problem is, what is the velocity of this low friction dynamics current? So we're going to say the velocity of the low friction cart was, we're just answering the problem, answering the question. We already kind of did in our analysis, right? It was negative 1.03 meters per second. That's what it was for me. For you, it's a different number. We just literally answered the problem. What's the velocity? It's 1.03. And then we got to justify it. How do we know that? Where did we get that number from? Where did it come from? The equation on the... Yeah. Now, specifically, what part of the equation? The y-intercept or the slope? Slope. So we're going to say this is known. This is known because the slope of the position time graph is negative 1.03 meters per second. Don't forget your units. If it's negative, don't forget your sign. We're just saying how we know that what we have is the answer to the question. Answer the question. And then, how do you know that's the answer to the question? Lastly, we're looking at sources of error. So we're looking for 2 or 3 good sources of error. Not wishy-washy things like equipment wasn't very good. Well, if there was something bad about the equipment, that's fair enough, but be specific. Like what wasn't very good about it? Does that make sense to you guys? Like if something was broken, okay, tell me by all means. If something you could tell was clearly inaccurate, tell me that, right? But don't just say equipment wasn't very good. Solution, buy new equipment. Like what do you mean by that? What wasn't very good, right? What was a good source of error here? Tell me something that could have been better than it was yesterday. It's hard when we're doing these electronic sensors, right? Because they work really, really well. We want to avoid human error here. Now, having said that, listen carefully, guys. There's a difference between human error and human error that's your fault and human error that is inevitable because of a problem with the apparatus. Like, if I make a mistake and it's my fault, I don't want to list that. If I can't measure data accurately, but it's a problem with the apparatus, then I can list that as a source of error because that's not my fault, right? If I'm speeding and I get stopped by the police, but there was no speed limit sign up, well, then I was still speeding, but it's not my fault that I was speeding if there was no speed limit sign up. Do you understand the difference there, guys? If there was a speed limit sign up, then it's my own fault. So we're looking for things that maybe you did wrong, but it wasn't your fault. Maybe it's just an issue with the procedure. Maybe the procedure could be better. Maybe the materials could be better. Who's got something that they want to try out here? Connor says, what about on level ground? Absolutely, right? The possibility of the ground not being level. Let's say that. That's one of the, I would say, Connor, in this experiment, that's probably one of the best ones. Possibility of the floor not being level. This could be improved by, you can word this any way you want. It doesn't have to be my wording, although it's okay to do my wording. This could be improved by, how could we fix that? Next time we do this experiment, we're not doing this, but next time, if we were to do it again, how could we improve that? How could we fix the possibility of a ground that's not level? Okay, so let's be specific. Don't just say, find the level ground. Well, how are we going to find a level ground? How are we going to know it's level? Like a construction? Yeah, like a construction level. I don't really know either, but let's just call it a construction level. Okay, this could be improved by checking the floor with a construction level prior to the experiment. Again, your wording doesn't have to be exactly the same as mine. Let's come up with at least one more here. Connor, that's an awesome one. 100% I would have used that one. Okay, so maybe there was a bump in the track or a divot in the track. Sure, sure. So let's say the possibility let's just say the possibility of the track itself being uneven, okay? Because that kind of encompasses a few things, right? This could be improved by checking the track prior to the experiment and replacing the track if necessary. Period 3 has told me friction on the track might have been an issue, right? I'm not going to put another one here, but friction would have absolutely been a good one. The possibility of friction on the track. Their solution was, let's clean it off. Let's wipe off the track to make sure there's no dust or anything on the track before that. Somebody said something about the wheels not working the greatest. Maybe we could lubricate the wheels. Yeah, that's a good one as well. Although I don't ever want you to lubricate those wheels, but that is a good possible solution to wheels that are sticking a little bit, right? So there's all kinds of possibilities. These are two good ones. We'll leave it there. All right, now I'm going to go back and tidy things up. And I'll give you guys an opportunity to tidy things up. Even if I'm going a little quicker than you are, we'll give you some time after I'm finished. I'm going to go back here and delete these instructions. I don't want to just highlight everything inside this magenta. I want to highlight a line before that. That way, when I delete it, it deletes the table itself, not just the words inside the table. Now let's go down here to this one, delete that. Make sure my spacing is good. Let's delete this one. I've listed all the materials. Says a photograph can sometimes be helpful. A photograph doesn't replace your list, but if you want to add your picture, you can do that too. Not necessary. Data and observations. Look at this. My data and you know what? I'll come back to that. Let's delete this. Here's my graph. Let's delete this magenta. Conclusion, more magenta to delete. And even more magenta to delete. I think that's good. Now let's just make sure that I don't have things all choppy like this, analysis heading at the top, at the bottom of a page, and then my analysis on the next page, right? We don't want, it's not very neat, right? So let's go up here. The first place that something like that usually occurs is in data. My table is spread over 2 pages here. Let's just start that on another page so that the data is all on 1 page. Okay, it is now. Now I don't want to skip a page, so let's start my analysis on the next page as well, so that I don't have my graph like half on 1 page and half on another page. Okay, the analysis questions are good there. They're not splitting the page. I'm going to bring conclusion up to the top of the page. I think I'm good. Now let's go back to the beginning here and just make sure everything is good. Title, yeah, constant velocity lab. Problem, what is the velocity of a low friction car moving on a horizontal track? I've got my variables listed here, all 3 of them. My materials or apparatus listed here, all 3 of them. My data and observations. Titled, title 1, or sorry, table 1. Everything is centered, nice decimal places. Yep, Alex? If you start at the top of the page and it goes over onto the next page, then that's okay. We don't want to start at the middle and then split the pages. You can't help that, right? If it goes on to the next page when you've got a page and a half of data, right? But if you've got a half a page of data and it splits a page, we just don't want that. That's a good question, Alex. Next is analysis. I got a little extra space here. I think I'm going to delete a space there just to tidy it up a bit. There we go. That's a little bit better. Okay, it's good. Oh, conclusion gets brought up there. I want to bring that back to the next page so that it's sort of tidier. There we go. Start that on a new page. Yeah, that looks good. I think I'm good. Before I submit this, though, and I am completing this as a student, okay, I've got a student account. So this is everything you see is exactly the way you're going to do it. This isn't from a teacher perspective, it's from the student account. Okay, the next thing I'm going to do before I submit this is to go into my rubric. So I'm going to go into my lab. I'm going to click on this rubric right here. This rubric is going to look different than the rubrics you've seen in the past. I think you'll like this because it's very detailed and it tells you exactly what you've done right and exactly what you've done wrong, not just generally what you've done right and wrong. Look, you get 29, 29. That's where we're starting. We're always going to start with 100%. And then we're going to take marks off. Instead of starting at a 0 and having to get marks, we're going to start with 100. We're going to assume you're going to get 100. And then if you make a mistake, we'll just take a mark off for that. So 29 out of 29, beautiful. Overall, neatness, order, general presentation, spelling. Have I made spelling mistakes? Is it neat? Yeah, I think so. I think it's pretty neat and tidy. Okay, I'm good there. Did I state my manipulated responding and control variable correctly? Oh, I didn't. If I didn't, then I would get a 0 for that, except that I did. This is my checklist, right? All materials listed, no extraneous. Did I list everything? I think so. Did I not mention the extraneous stuff? Like all that irrelevant stuff? Yeah, I think I left out all that stuff. Let's just go back and take a peek again. It looks like my materials are good. Okay, so we're good there. Data. Did I collect all relevant data with nothing extra? Any extraneous data? Any little, like somebody earlier, I saw their data and they had that little uptick at the beginning. They should have deleted that data, right? That little uptick at the beginning. That would be extraneous data. That would cause you to lose the point there, right? So just delete that. We don't want extraneous, extra data. Is my table titled? Are my units recorded? Is it presented neatly? Analysis. Do I have the right graph with the axes positioned correctly? Yeah, looks like it. Is it titled correctly, including my initials? Right? Oh, shoot, I forgot to put my initials on. I better go back and fix it, right? Nice little reminder for us if we look at a rubric before we submit it in. Did I do my trend line, display my equation, the slope? Did I put the units in correctly? Did I answer the analysis questions correctly? Did I present it neatly? And is it organized? Yeah, I think so. Did I state my conclusion? Did I state my conclusion? Yeah, the velocity is negative 1.03. Did I justify my conclusion? Yeah, this is known because the slope of the graph is negative 1.03. The slope of the graph is negative 1.03. And finally, my sources of error. My apparatus, materials, procedure, weaknesses evaluated. Did I do that? Did I come up with 2 or 3 good sources of error? Yeah, I think so. And then finally, did I make suggestions for an improvement? Specific suggestions for the improvement of it. Not just like make sure that, not just make sure the floor is level, but how do we make sure the floor is level? Use a construction level to make sure the floor is level, right? Be specific with your suggestions for improvement. Now, if you have, you weren't sure what that level was called, right? If you name it slightly off of the actual term, we're not losing sleep over that, right? You're still being specific. We just don't want to say like, check the level next time. Well, how you check the level? Check the level using a construction level or whatever your term is for that. There's a few ways to do that, but that's one possible solution. And then that's it. Okay, I feel pretty good about this. So now what I'm going to do is go back to my lab, and I am going to turn it in. Now, technically, this isn't due till Monday, so anytime before Monday, you can actually unsubmit this and make changes to it if you're like, oh, wait a second, I think I missed this. I don't want you to second guess what you've done once you've turned it in. And if you're talking with somebody and you realize you missed something, you can always go back and unsubmit it until the due date. After that, you can't.